Hey everybody, welcome to today's lecture for mobile computing. Today's lecture is lecture 3 and we'll be talking a bit about Java. So you guys have been using Java for the labs, hopefully. If you haven't, please get started on those. And this lecture will cover some of the things that are interesting about Java. So what's this lecture for? Why are we having this lecture? You guys know that lectures about programming are generally kind of pointless. You discover most things about programming by programming, right? I often like to say to people that programming is a lot like soccer. You can watch lectures about soccer or read books about soccer or any sort of thing, but you'll get good at soccer by playing soccer. Programming is very similar. So most of the things that you need to know about Java, you're going to discover by programming in Java. Okay. There's some material on Moodle. There's some Java slides, and there's a link to a free online textbook if you want to use it. I won't cover much of it, so please take the time to go through the stuff that's in the slides, as it'll definitely help you with coding your labs. But what I'm more interested in is what's different to C++, because you guys are familiar with C++ and you've used it a lot last year. So we'll talk about some of the things that are different as compared to C++. And we'll talk a bit about object orientation. I think you guys did a little bit about object orientation last year, but we'll do a bit more on it in this course. Okay, but first we're going to have a logic puzzle. If you remember last week's lecture, the question was, what is app development about? And the answer was solving problems. Now, what I've found over the years is that a lot of the time when students are given a problem to solve, the first thing you'll do is open up your IDE or your text editor and start typing a program. And it doesn't really make sense because you can't program something unless you've solved the problem you're trying to turn into a program, right? There's a solution that you turn into a program. You don't start off writing a program as a solution, if you get what I mean. You first have to figure out how the problem is solved. And one way that I get around this is I'll give you guys these abstract problems, and the idea is that you just need to solve these. Okay, so here's one for this week. This is just a logic puzzle that I think is pretty cool. So in this puzzle, there's 3 boxes, and one contains only apples, one contains only oranges, and one contains apples and oranges, right? The boxes are labeled, but the interesting thing is that all the labels are wrong, right? So the box that's labeled apples isn't the box that contains only apples, and the box that's labeled oranges isn't the one that contains only oranges, and the one that is labeled apples and oranges isn't the one that contains apples and oranges. Okay. Now what you have to do is fix these labels. So that means you have to in some way determine which box each one is. What you're allowed to do is take one fruit from one box. Note, this is important. Not one fruit from each box, but one fruit from one box. Okay. And on examining that fruit, you should then be able to correctly relabel all the boxes. Okay, so the logic puzzle is, well, how would you do this? Okay, so this is it's a logic puzzle that's fairly popular on the internet, so you may have heard about it before, and it's certainly very easy to Google it and Google the answer. But that'd be kind of cheesy, right? Like, this is not for marks or anything. Just do it because it's cool and do it because it gets your problem-solving mechanisms moving. So yeah, think about it for a while. What I would like from you guys is to message me on Discord with solutions. I do find that every year, not for this puzzle in particular, but for lots of puzzles, I get lots of different solutions, not the ones that I necessarily would have thought of. And it's actually quite cool to look at. Okay, let's get back to real work. Okay, so what makes Java different from C++? Well, you've seen some of Java from your labs, and you'll have noticed that the syntax is quite similar. A for loop in Java looks pretty much like a for loop in C++. An if statement looks the same. So I'm not really going to go through that. One cool thing about Java is it does have a lot of standard APIs that help with stuff. So there's a lot more built-in functions in Java than in C++, and you'll get to grips with these through the course. But also you can take a look at the API documentation that is linked to in your lab. But one of the most important differences is that memory management is handled through garbage collection. So in C++, you had to make destructors for your class, and you had to call delete on any data structures that you created, or you had to, if you used malloc, you had to call free. Basically, memory management was your job, right? So you had to say, I've created some data structure to store something, and as soon as it's finished, like I've got to manually free up that memory. Okay, Java doesn't work that way. Java uses something called garbage collection. How this works is that you create objects, and Java will keep track of how many of those objects are in scope. So if at any point there is no reference to that object that's in scope, it'll get deleted by itself. The garbage collector will kick in and say, nope, this variable is not needed anymore. Let me remove it. And there's advantages and disadvantages to this. The big advantage is that, of course, you don't have to care about memory management. That's a pretty big deal because memory management is hard. As an example, they're still finding memory leaks in Google Chrome and Mozilla Firefox. And these are some of the most popular, well-used open source projects with tons of developers, and still there are memory leaks, right? That tells you that this is actually a super hard problem. If memory management is not handled by you, if the garbage collector has to handle it, it becomes just not your problem. The disadvantage, however, is that you have no control over the memory management. So the garbage collector will occasionally kick in and go and delete variables that are no longer necessary. At some point I wrote a car game in Java. You could like race this car around and stuff. And one big problem with it was that whenever the garbage collector kicked in, your frame rates would drop to like horrible frame rates, and you just basically, your car became undrivable while the garbage collector kicked in. And there was nothing I could really do about it because memory management isn't controllable in Java. Okay, there are clever techniques, but I wasn't that clever at the time. I hope I'm cleverer now. Okay, so when it comes to the types that you can use to store things, you'll see they're quite similar to the ones that you had in C++. You have booleans, bytes, integers, longs, floats, and doubles. And you also have char, which I didn't mention here, which stores characters. And any of these can be in an array, I guess. So if you look at boolean, it's just a 1-bit value, right? It's either 0 or 1, or sometimes we refer to them as true or false. Okay, you've got a byte value, which goes from -128 to 127 because it's 8 bits, and that means there's 256 possible values. Integers are 32 bits, so that means there's around 4 billion possible values split up into the numbers from -2 billion, to positive 2 billion. So that's like 4 billion numbers. There's long, which is a bit bigger, so it goes from -10 to the power 19 to positive 10 to the power 19. There's float and there's double, which have the ranges specified on the slide. Why am I talking to you about this? It is in the slides, you'll see it. Why is this interesting? Well, there's a couple of interesting things about this that I want to tell you about. One is that you should care about this, and it's often something that people don't care about, right? So you might say, well, I've got a numerical value, so I can just store it in an int. Okay, seems legit. It doesn't have any decimal points, so mathematically it's an integer. So let me store it as an integer. Well, you must remember that because an integer is 32-bit, it can only store values from -2 billion to positive 2 billion. And if you try to go above that, you'll get an exception. So basically some error that will crash your program. Okay. And there's a very popular story we tell in CS about this, which is about the Ariane 5 rocket, which was this rocket that's meant to take satellites to space. It costs hundreds of millions of dollars. And on one of its test flights, the Ariane 5 crashed. And the reason it crashed was quite interesting. It was because they used an integer to store a number that was going to go above the range. So at the time, integers were, well, in their software, it was a 16-bit value, right? So 16 bits means that the maximum number of things it can represent is 65,535. Hopefully you guys remember that from, or 65,536. Hopefully you guys remember that from BCO. And if you're using integers that way and they're signed, meaning they have a positive or negative value, that means you can go from minus 32,767 or minus 32,768 to positive 32,767. The trouble was they were using this to represent a velocity when the Ariane 5 could go faster than that. So what happened was when it got to 32,768 and then tried to increment that value, an error happened and the rocket crashed and they lost something like $300 million, if I'm not mistaken. So you've got to think about these types. It's pretty important. Another example that might be interesting is like South African ID numbers, right? You think about these ID numbers, well, they seem to be numerical. They don't have decimal places. So yeah, let's call them an int. But remember, an int only goes from minus 2 billion to positive 2 billion. So that's 2 times 10 to the 9. But an ID number has 13 digits. So it won't fit in an int. Okay, so there are real world situations where you have to think about this stuff. Another interesting one is the floating point numbers like float and double, right? So you can see those ranges. They look interesting. Look at float, which is 32-bit. It goes from minus 3 times 10 to the 38 to positive 3 times 10 to the 38. 10 to the 38. So it's 3 with 38 zeros behind it. That's some ridiculously large number. But it's only 32 bits. If it's 32 bits, that means it can store 4 billion possible values, right? 4 billion is only 4 times 10 to the 9. So how is it that it can go from minus 3 times 10 to the 38 to positive 3 times 10 to the 38 and represent fractional values in there? Well, this is an interesting question, right? Basically, we're saying it has too few possible bit patterns to represent all the numbers that have it. Right? So it's kind of like in your class of 200 people. If I said I can only hand out 5 cans of Coke, right? There's 195 people that aren't going to get cans of Coke. Similarly, don't worry, I wouldn't do that to any of you. I'd buy 200. It's just but if in this representation, basically what we're saying is that out of that 3 times 10 to the 38 possibilities, most of them just will not end up with a representation. They just can't be represented. So I've made a project called Lecture 2, and I'm just going to put some example in here. So I've created a main method, which you guys remember from, it's very similar to int main, but you'll also have seen it in the labs. Okay, so let's say I create a double value, right? Double f equals 1355.65. It's just some double value. And then I'm going to print it out. Okay, if I run this code using Eclipse, if I run this code, you'll see the value 1355.65, right? And that's what you'd expect, right? I said that's the value I put in and it printed it out. But let's look at something interesting. Let's say I said print out f minus 1000. Okay, so I've got 1355.65, so you'd expect the value to become 355.65. When I run it, I get 355.65 not 1. That's an interesting thing, right? The reason that happens is because 355.65 is one of those numbers that is just unrepresentable using a double. Okay, so there's sort of gaps in the system. So if you need like extreme precision, then you want to not use float or double. In fact, double is generally better than float because being 64-bit, it has better precision. And so when you have a choice between float and double, generally you should use float. But if something is like super critical, don't use either one. You can represent fractional values using, in Java, the object's big decimal. Don't worry about it for now. Just know that it exists if you happen to need extreme precision. Okay, the other thing Java has is object orientation, which is a way to create more types. I think you have seen some of this in C++. And in object orientation, there's two very important terms that I want to define here. One is a class, and a class is like a specification or a design for something, right? So it's sort of like a type. So if you had like a car game, you might have a class for a car, so that there's a type car or a type track or something, right? So those are called classes. And classes have variables so that they can store all the information that's necessary. For instance, if I had a student class, I might want to keep a first name, a last name, an ID number, a student number, an address, some array of courses or something like that. So that's the variables. And these classes would also have methods. So that's like functions that operate on the variables in that class, right? But remember, like I said, classes are like a specification. Then I also have objects, which are what happens when I instantiate a class. So those are like concrete things, okay? One way to think about these is if I said this is a something and I could fill in that placeholder, that something would be a class. So if I said this is a car is a class. Objects have like this is placeholder. So if I said this is Steve, then Steve would be an object. So as an example, let's say I said car, right? We said that would be a class. If I said Toyota, what would that be? Well, would you say this is a Toyota, or would you say this is Toyota? You'd say this is a Toyota, right? So Toyota is also a class. A Toyota is a type of thing. But if I said Pravesh's Toyota, then you wouldn't say this is a Pravesh's Toyota. You'd say this is Pravesh's Toyota, right? So Pravesh's Toyota is this sort of concrete object. It's something that exists in the world, whereas Toyota is almost like a conceptual thing. It's not a physical thing where you could say this is Toyota. I mean, I guess. I guess the analogy isn't perfect. But yeah, that's the difference between classes and objects. But why? Why do I have object orientation? Well, the main reason is it helps with abstraction. And you've probably all heard that before. You've heard it helps with abstraction. And you're probably going, well, that's not particularly useful. What does that mean? Why do I care about that? Right? Why do I care about abstraction? Well, yeah, that's a very good question. So abstraction is the ability to just like forget about stuff, right? So I don't want to have to keep every implementation detail of everything in my head. I want to be able to forget about stuff and focus only on the things I need. And this becomes super important when we take into account some research from psychology. So research suggests that we can keep 6 or 7 things in our head at any given time. Just 6 or 7. Now, can you imagine if you're the person implementing like Microsoft Excel or something? There's way more than 6 or 7 things in Microsoft Excel, right? So the key is being able to forget about all the things that are irrelevant to you at the time and focus in on just the things that are relevant, right? So we care about abstraction because we have to. Our brains are not designed to keep millions of pieces of detail in our heads, right? So we want abstraction to allow us to forget about stuff. But how does it help with abstraction? Well, the thing about it is when things are encapsulated into objects, right, then they become not our problem anymore. So for instance, you've encountered you've encountered code that looks like scanner in equals new scanner system.in, which reads from the or creates an object that can read from the keyboard, right? So this thing created an object called in, which was of type scanner. And that object in is sort of like, it's a module of its own. It's got its own variables, it's got its own methods, and it's not my job to think about it. I don't care how it works. If I want a string to come out, so string value equals in.next line, I don't care how next line works. I don't care that it has to wait for an end of line character or some sort of null termination. I don't care that it then copies all the characters into some buffer, and from there it copies it into the variable and it makes the variable accessible to me. I don't care about any of that stuff, right? The main thing for me is that it does it. I don't care. I don't care how it does it. So the abstraction kicks in there. All I need to know is I want something that reads from the keyboard. Done. Right? So that's pretty cool. Object orientation allowed me to accomplish that. Similarly, I could say I want to do something with this string. Okay, so let's say I want to print it out, right? System.out.println. But I don't want to print out the entire value. I want to do something with it. Maybe I want to turn it into a capital letters, into uppercase. So say value.to uppercase. Right? So you can see those suggestions came up and they tell me what to uppercase does and stuff. Converts all of the characters in the string to uppercase. So that's what I'm looking for. So I do that. Let me just comment out that thing. So if I run this now, if I type hello, it prints out hello. And I don't care how it did it. I don't care whether that was an ASCII character set or a Unicode character set. It's not my problem. I don't care whether they made a new array of characters or something. Whatever. Not my problem. I wanted it to be uppercase. It's uppercase, right? If I had to keep all of those implementation details in my head, I'd forget what I'm actually working on. In this case, nothing, so that's not particularly important. But in general, that's a problem, right? If you end up forgetting what it is you're working on, that's going to be a problem. But this sort of abstraction definitely helped here in that I could focus in on what it is I actually wanted to accomplish. Just for the record, I'll be coding like that a lot in this course. I find watching people code is helpful to learn how to code. You'll probably learn a lot of my pretty lousy habits that way, but hopefully some of my good ones as well. So why object orientation? Well, it helps with abstraction. It helps with code reuse because I can just use somebody else's objects without understanding them. So abstraction itself helps with reuse. One of the things I wanted to talk about is the word public and private. Okay, so you've seen public static void main, right? You could potentially also see something like public get public string get some value. I don't know. That's a method that I've just created, and all it does is it returns some value. Now I could say system.out.println get some static string. Ignore the static part. I'm focusing on the public part for now. Get some value, and I'm going to get rid of this stuff about the scanner. Okay, so if I print it now, if I run the program now, it prints out some value because that's what this get some value thing returned, right? Now, by making this thing public, what I've said is that anybody who uses the typeExample class can use the get some value method. If I made it private, I'd be saying it can only be used internally to this class. Okay, so now let's take an object-oriented approach to this thing and create another class to store this method. Let's call this class maybe like value getter. I don't know, value store. This is a very random and artificial example. So let's say we had public void get some value, and it returns, okay, I'm going to make it say some other value for no reason other than I feel like changing the thing. Okay, and it shouldn't be void because it returns something. It returns a string. Like I said, I'm just randomly coding, so you're going to see me screw up and you're going to see me type stupid things. That is also a useful thing to see, that nobody codes without the help of the IDE, and nobody codes without screwing up, and it's all entirely normal. Okay, so the first thing I'm going to do is I'm going to create a value store object from my value store class, right? Then when I want to use this get some value method, I can say vs dot, and the IDE will tell me what methods I have available. So in this case, you can see there's get some value here. So I can do that. And I get this sort of some other value thing, right? So having multiple classes is not difficult. I just make another class and I can create instances of that class and call methods from it, and everything's fine. Now let's say some other value had to do some calculation. Okay, so let's say what I actually wanted to do was some other value plus 13 times 8. I am coding such random nonsense. But anyway, let's say I wanted to do something like that. And then I decided, you know what, that 13 times 8 deserves its own method. So I say, okay, let's make public int get stupid calculation. Get stupid calculation. Don't learn my terrible naming conventions unless you're writing functions that are as pointless as these ones are. Okay, so that thing returns 13 times 8. Then I could say in get some value, I want to return some value plus get stupid calculation, right? Then over here, when I run this thing, it'll return some other value 104 because I have that 13 times 8 in there. But here's something interesting. If I say vs dot, I have access to that get some value method and that get stupid calculation method, right? But what if I know beforehand that this get stupid calculation method is only ever useful to this get some value method? Nobody else ever wants to call this get stupid calculation method. Then what I can do is I can make it private. Okay, and that means that when I look at the methods that are available from here, there's no get stupid value method, right? Because it's private, this class can't see it. Okay, so it being private helps with abstraction simply because this class doesn't even know that that method exists. There's one less thing that someone using the value store class has to think about, right? Because they're just going to go, well, what's accessible from value store? The only thing that looks interesting is this get some value thing. Okay, so by making something private, I've stopped external parties from having to think about what this method does, right? If it was public, when I'm coding here and I've got to decide what method it is I want to use, I'm like, wait, maybe this get stupid calculation is the one I want. And then I suddenly have to think about it. And I do not want to think about it. I'm a very lazy person. So I see there's only get some value there, and it's fine. I'll just use that one. It's cool. Okay, so that brings me to the sort of private public distinction. It's there for abstraction, right? It's there so that it allows us to forget about things that are not public. Right? If it's not public, I don't have to think about how it works. As soon as it's public, I can see it, and so I care. right? Or a user. Let's say a user of this class can see it, and so they care what it does. If I make it private, I'm making it very clear that no one should care about this, and so just forget that it exists and go away. So that's the difference. That's what public and private is about. There's some intuition in your head that says public and private are for security. They're not really for security. That would be bad security, because the variables are still just in memory and accessible, and you can do stuff with them. The value to making it private is that someone doesn't have to think about it, so it helps with abstraction. Okay. Okay. In that vein, we also have we can also use variables from here. Let's say in here we had an integer like I don't know, age or something, right? If we wanted to access it from here, we could maybe say vs.age equals 42, and maybe here we want to print out the person's age, so we print out plus vs.age. Okay, and I mean, yeah, that's pretty straightforward. It works, but I just wanted to give you an idea of the syntax, that if I have variables in here, I can access them, right? We generally consider this to be not such a good design, because I can put anything I like here. There's no validation, right? So I could say, let's say this was meant to be a person's age. I could put like that in there, and the program would work fine. And that doesn't really make sense, because that's not anybody's age, right? So one way to sort of make these variable accesses a bit safer is you could say, let me make it private. I don't actually want people to access the age variable directly, because they might screw it up like this guy did. But then I can't now use the variable, right? So what I do then is I make methods that manipulate the variable. So I can make a public void set age, which takes in an integer, and all it does is it sets, okay, let's call it age sh. Then I could say age equals s underscore age, and what that would do is this method would receive a parameter called sage, and it would copy sage into the age variable, right? That's what equal to does. Equal to is not the mathematical equal to which checks for equivalence. It's a copy operator. It copies the thing on the right into the thing on the left, right? So that means here I could say vs.set age that, right? And now what would happen is it would receive, the set age method would receive this awful number, and over here it would then set the age variable, right? And then when I want to print it out, you can see I can't, because age is private. So what I can do instead is I can say public void or public int get age, and that returns age. Okay, so that means here I can now say vs.get age, which will return the age that I stored, and I'm back at my original program. Okay, which you may think, well, what was the point of that? Well, the point of that was now no one can set the variable directly. They have to go through my methods. So if I want to, I could say if sage is greater than 130. Okay, if sh is less than 130, then set age equal to the value, else just set age equals to 130. So basically what I've done here is I've said that if the age is less than 130, fine, set the age as you would normally. But if someone sends a value greater than 130, don't let them, just set it to 130 for them. So now you'll see when I print it out, I get 130, even though what I sent in was this number, which I'm not going to try to pronounce because people will make fun of me. Kids can be so cruel. But I can do this sort of thing. Similarly, if I wanted to, I could I could mess with the way the storage is done in value store, and because of abstraction, it may not matter. So let's say I wanted to instead store the age as a double. I could still have a get age that just returns the age casted to an int. And the advantage is that someone using my class, so if type example uses value store, the internal representation in value store has changed. It was an int, now it's a double. But type example doesn't need to care. It just keeps going and it works as if nothing had changed inside value store. This is extremely useful in multi-person projects or projects that use code that's from other projects as well. Simply because otherwise everything would fall apart, right? Every time I change something, everybody else would have to change all their code to accommodate. But what having public and private does, it just allows you to define the gateways into your class, if you will. So the public things are the gateways into your class, right? And as long as those things behave consistently, there's no problems. You can change the private things without damaging anybody else's code, which is a really powerful thing. So this is one of the reasons we have private and public, and why we use these getters and setters. Okay, it's worth coding them yourself a few times, but I'm going to show you something quite cool in Eclipse. Is if I have a variable, let's say student number or something, and I know I want it to be private and all of that, so I just go to source, generate getters and setters, and change the modifier to private and say generate. No, wait, let's not do that. I don't want the accesses to be private, so I'm going to say source, generate getters and setters, and tick them, make them public. And when I say generate, then there are now getters and setters. So I'm going to say private here, and you can see that there is a public get student number and a public set student number, and they do what you would expect them to do. Okay, I think you guys may have heard my kid cry there, but it's useful because it's okay, because we're pretty much done. I think he is waking up. Yeah. Okay. Okay. This this thing about why object orientation and then it helps with abstraction, and why abstraction reminds me of my 4-year-old, because anytime I say something, he goes, why, how, why, how? And that's great, because it makes me think about all the things I don't know. He asked me, Dad, do you know everything? And I'm like, yes, of course I know everything. So he's like, how did the world get created? So I start telling him about the Big Bang and how the planets and stars and everything came from the Big Bang. And he says, but then I have a more difficult question. How did the Big Bang get created? And I'm like, I guess your dad doesn't know everything. And on that note, that's a reassuring thing to hear from your lecturer. I do not know everything. I certainly don't know how the Big Bang got created. But on that note, thanks everybody for listening to me. I hope it was useful. I hope we'll have a very good lab session this week again. If you're not participating in the labs, please do so. These labs are a big part of what makes university fun and interesting, just because you get to interact with lots of smart people about lots of interesting things. Okay, thanks everybody.